It met road legal safety specifications. It held 4 adults. It was ugly. Aesthetically challenged might be the right word. It was, before this was designed, there weren't any cars that achieved over 100 miles per gallon in the United States. On the German test cycle, that's about 2.5 liters per 100 kilometers. I don't know what that is on the Indian test cycle. It's about double the Toyota Prius. So it might be around 1 liter per 100 kilometers on this test cycle. I'm not sure. It's about double what the Toyota Prius is. But we knew that if people were going to drive these things to work every day, if they were going to really love these cars and we were going to make a difference in urban air quality through lower emissions, it would need to look good too. So we iterated, and about 6 months later, we had this carbon fiber Le Mans style car body, and we just set it right on top of all the other components. Then someone sent us this drawing, and we loved it. Rob Moorbacher in Germantown, Maryland. And previously, I'd never met him in person before. He drew this on his own time because he said, this is beautiful and I want it to go on this ultra efficient car. And we said, yeah, we want that too. So we made it. And at Agile 2012, in August last year, it was in Grapevine, Texas, WIKISPEED got to do the closing keynote. And we unveiled that car in carbon fiber. That's the car we sell now, the WIKISPEED Roadster. And that's what I look like when I'm really, really happy. That car was built backstage in 3 hours. We sent out an email to conference attendees, just like this, saying, get hands-on experience with Agile for hardware. Come spend an hour and a half with us. We ran 2 1.5-hour sessions. These people had never seen a WIKISPEED car before. They had never taken any training from us. What we did is we posted a backlog of what it takes to build one of our cars, and we paired. Here's Emre Aras. He's our intern from Turkey. He's leading a swarm working on the rear suspension. Clayton Osterman, our Scrum Master, is joining that swarm, seeing what they need to go faster. Here's Tom Tabor. He's in a swarm working on the carbon fiber car body. And this swarm is working on the frame, the chassis of the car that holds it all together. And I was in that swarm, but I just stepped back to take a picture. So we had a backlog and pairing and swarming. We didn't give any instructions. We didn't have any instructional videos or instructional manuals. We just got to work. And 3 hours later, we built a car. Those folks can now build their own WIKISPEED car if they want to, because we published the WIKISPEED car for free and open source. I hope Tata Motors, Ford, Hyundai makes an ultra-efficient car that gets over 100 miles per gallon and is extremely low cost. I hope they take some of this idea. Until they do, we sell them and make them available as a nonprofit. How do you make an increment of a physical product in a single iteration? Even in software, it's really challenging to get down to a 1-week sprint cycle. Some teams do it. Some people have continuous integration and continuous deployment, and they have a functional release that's tested every hour. But that's uncommon. It's still hard even in software to do a 1-week iteration. How would you possibly do a 1-week iteration in hardware? It requires object-oriented engineering or modularity. This is the best we believe of what makes this possible. This is what we think is new, what is different. If you think about software and you have a code base and maybe it's a few million lines long, imagine if it was a procedural programming language with go-tos and nested loops all throughout. And you were told, change the login system in 1 week. There's no test coverage. It's not split into any objects or classes. It'd be very difficult. You'd have to have complete comprehension of the entire product, and you'd have to unnest those pieces to figure out which part represents, which spaghetti represents the login. Enter object-oriented programming. Suddenly we have classes, modules, and layers that we can swap in and out, and they're meaningful. And you can focus on just that piece, and you have test coverage to know if everything else still works. When we do that for hardware, we're then able to go on iterations that are the same speed as software teams. Here's what our car looks like underneath. It's 8 modules. So you could think of it like 8 layers or 8 classes. We have our suspension modules, and we're able to switch those from any type of suspension in about the time it takes to change a tire. Our engine is a module, and we're able to switch it from gasoline to electric in about the time it takes to change a tire. So some people might ask, is the WIKISPEED car gasoline or electric? It'd be like saying, does your computer come with a mouse or a trackball? You just switch it. Same principle applies. The body switches from a convertible to a family car to a pickup truck. This level of flexibility is new, and it lets us iterate quickly. Here's a CAD of the 2D side of our suspension modules. This is exactly what they look like if you look at them on the side. Here's the left side, and here's the right side, and there's the other right side. I went shopping for aluminum 3 days ago, to see if we could actually build a physical car here in just 1 hour, which would be a whole new feat. I wasn't able to find the right size aluminum. What we did do is we made a whole bunch of paper 1 to 10th scale WIKISPEED cars. If any of you guys have ever done origami or paper craft, where you make something out of paper, like a little boat or a swan or a car, the complex ones, we're going to do it in modules. And we're going to use the actual WIKISPEED CAD. What we did is flipped it on its side and hit print. And we'll be cutting these out and gluing them together over the course of this next hour. I wish I could say you all had built a full-scale WIKISPEED car out of aluminum and carbon fiber. I wasn't able to get the materials, and I'm not sure we could do that in 1 hour anyway. 3 hours is the fastest we've done it before. What I will be able to say at the end of this session is not only have all of you heard the concept of extreme manufacturing and the principles that make it work, but you've done it in miniature. You will be able to say you have hands-on experience with Agile for hardware in an automotive context. This is hardware paper prototyping. If any of you have ever taken a web page and written where the menu goes and the links to other pieces of paper, and handed that piece of paper to a user and said, where would you click to log in? And they draw a little blue X. And you say, okay, well now I know what your expected behavior is before I've even written any code. This is that for a car at a time. Again, this is new. This lets us then take some of the practices that are working well in software and apply them to any domain. And we'll use cars as the example, because that's what I know the most about. That's what I do after work. Here's a finished product of a 1 to 10th scale WIKISPEED prototype. Here's a definition of done, showing how these 3 modules fit together. We have 3 of the 8 modules prepped today. We have a chassis module, a suspension module, and what's called the control module, or the pedal plate. It's what has the steering rack, the brake pedal, the accelerator pedal, all on there in miniature. And we'll be using scissors, tape, and then these are the printouts of the CAD. And we'll be mapping them to the definition of done. We'll be using Scrum for this. Every WIKISPEED shop, well, maybe I should let you know, there are shops in 20 countries now. There's one just starting now in Pune, there's one starting now in Mumbai, and there is one in Bangalore right now. So after the conference, if some of you folks want to build, say, a WIKISPEED modular, ultra-efficient and safe auto rickshaw, you can. That exists here. Every WIKISPEED shop, in order for it to be a WIKISPEED shop, has these 5 things. So we're going to turn this room into a WIKISPEED shop. It needs to be always open. This is only the concept of eliminating barriers between people who want to do awesome and the tools to let them do awesome.
We will open the door to allow that 24/7 access.
Yeah, we thank you so much for implementing the principle. So folks can come in anytime if they want to. So step 1 is find a place that can be open 24/7, 365. And then label it on the door. How this often happens is we'll have a lock with a digital keypad, and anyone who's joined the team gets the code. And we say you can invite in anybody you want, but then it's your responsibility to make sure the shop is clean and safe when you leave. Then every shop has a safety shelf that's clear and visible. So as they walk in, they're able to see all our safety compliance issues. In the United States, that's legal requirement, OSHA requirement. So that's where we'll have a fire extinguisher, dust masks, eyeglasses, hard hats, welding gloves, thick leather aprons for working with sharp objects. We'll have material safety data sheets for any chemicals we're using in the shop, because we're a real production facility. Here we'll have a Band-Aid, because I'm hoping working just with these scissors, that's all we need, and I hope we don't need that. Then we have a snack shelf, just as important as the safety shelf. We've noticed low blood sugar, or someone thinking they just need some water, or a beer, or a healthy snack. It is a complete necessary piece to be able to cure that immediately. In this case, we've got a whole conference with a snack bar outside, and we've got the water bottle area. Okay. Then we have the tool shelf, and the concept there is that every tool we have is visible at once. So we don't use cabinets, we don't use drawers, because then you can't see what we have. There's just one visible place, and if any tool's left out that's not being used, people know where it goes back. Now we have lots of tools, so we have these wide shelves that hold all of them visible across 4 bays. Then we use a Kanban board, and again, if you remember I said, since people's lives depend on these things, their cars, and then some of our clients' cases, airplanes and military mechanisms, it's got to be test first. It has to be test driven. So the backlog is explicitly the backlog of tests. If something starts as a concept, we write it as a user story, and that user story is first written as a test. Then we're ready to build it. We have to know when we're done with safety before we can even start. Here's the cards that label each of the 5 practices. They're up here, and what I'd like you guys to do is attempt to self-organize and take each of these 5 cards, they're labeled 1, 2, 3, 4, 5, and they're in that bag right there, and tape them somewhere on the wall where there's area on the floor under them where we can set the tools we're going to use, where we can set the Band-Aid for the safety shelf. So let's turn this room into a WIKISPEED shop. Here's the 5 practices, and we'll be taping these 5 things up somewhere in the room. Let's self-organize to try to make it true. People know where safety supplies are, so if somebody were to cut their finger, they know where to go. They know where snacks are. They know where all our tools are. Let's see if all the tools are out. Oh wow, they are all there. We're set. And then we have a Kanban board. Now there's not tests populated on it. 4.6 people, statistically, are the highest velocity teams. So 4 or 5.
I'm the fine 6.
4 or 5 people. Traditionally, back when the Agile Manifesto was first written, Scrum was first coined, so 2003 when Agile Project Management with Scrum came out, the data at the time suggested 7 people plus or minus 2, so 5 to 9. After running hundreds of very well documented Scrum teams through thousands of sprints, the data now shows the highest performing teams are on average 4.6, so 4 to 5 people. So 3 to 9, but really let's fill the space we have, because we'll be working collaboratively in these groups. So let's join up and self-organize into teams for each cluster of chairs, so we can build some cars.
In the center, there's a table simulation, so you will need a table for doing the work. maybe around that, however you want to collaborate. Some extra chairs there, more chairs.
So each of the teams can also write a full name for your team.
You already put it.
Place it
Awesome.
Okay, so
Now everyone was copying it here.
This is what Indianized.
And then, Babu Srinivasan, could you raise your hand? Okay, so Babu Srinivasan, I'll like to ask you if you'll accept it to be our product owner as this sprint gets going. And if you remember, it's a Kanban board of tests. So I'll be asking if he's willing to write some work phrased in the form of a test so the teams know when they're done. Would that be okay with you, Babu?
Yeah.
Awesome.
So, is there a theme for naming our teams?
full name like
Okay, we'll name it Bud.
Raise your hand when you got the name and shout it out. What's the team name? Bud? Bud. But maybe we might make a modular auto rickshaw. But then through papercraft, if you guys could make a transformer in a way that it looks kind of like the WIKISPEED CAD as we bring it up, we could build it. So maybe this group will even add some depending on how timing goes. Or maybe I'll get a Facebook link with a picture a few weeks from now saying, we did it, here's the papercraft transformer, now build it. And we'll be like, okay. This group, what is the team name?
Hanuman.
What does that mean?
God.
Flying
Car Maruti.
Flying God?
Yes, flying God.
Then let's do that. Awesome. Let's be Hanuman. The team back here. Do you guys have a team? Oh, awesome. If you read it to me, even though I can read it. Awesome. Although we might have some copyright infringements with Mazda, because they're Zoom. But I think it's good. Let's go with it. And then our team in the very front. The fastest team so far. We'll see if the velocity stands, but love the name. I'm really surprised I didn't hear Dasu. Because if I understand, that means like fearless and awesome. What could be better? Why would you ever name yourself not Dasu? It's so good. You guys have excellent names. Thanks for self-organizing in that part. Now, let's build some cars. But often, our tests are things like, as a user, I can drive to work at 100 miles per gallon. And anything that solves that problem meets the test. We quickly know when we're done, it's testable, we invest in the test fixture, the machine that measures our fuel economy, the rolling dynamometer. So it's right there ready to test, but we don't have a design yet that passes the test. So usually they're more open-ended. Dr. Srinivasan.
I also want to say that as a product owner, I'm looking for a high-quality car. So when you build something, the definition of done of this product is going to be that it's high. You can take it and literally throw it down and it should not break. Right? I mean, the car should not break. So when you build something in a few minutes, it should not like fall apart or it should be like undone. Well done cuts, perfect cuts like this, and should be just perfect. So we can actually, the definition of done for me is if I take it and drop it, it should not break.
Awesome. So
And that's my definition of done. That's a test for me as a product owner. So I will actually do that in your car. So be ready for that.
So folks, now let's try to build it. Now, you've got pieces of paper that are about to be handed out per group, and there's going to have to be some self-organization. Feel free to ask JP or Babu or myself, but you're just going to be given pieces of paper and trying to translate it into that with only those tools. This is the challenge. There'll be 3 modules. This is the first and most complex one, so we're starting toughest first. Your table will be getting a packet. I wish you luck.
The second, it's all your setup, so keep it ready so we'll tell you what it is.
Each group should have 4 pieces of paper.
You should have 4 pieces of paper, yes? Okay. Do you all have it? Here's the first part. So, if somebody wants to do the first story doing progress, please.
Would someone model the Scrum Master and take the first card and put it in progress? That would be awesome.
So only the first piece, so we don't want to do everything.
In this case, we need everybody to do work. So yes, they'll be able to support the team, and we'll be supporting the team. We have a product owner and what we're doing.
This entire thing comes together. No, but like this. Something like this. Yeah, that's a good. I was just wondering, will it add any value? Like if we, I think it. Lucky phone.
Four on the other side, so these three are like this. You guys have done it?
I have the mechanical lab. Okay. People can go and actually build this.
You mean as a project work? What is it?
College going kids you want?
Because of the folding, it is a little twisted. Redo it.
No, but if you do it like this, then you might get a call. Okay.
A little twisted. Ridiculous.
The reason why is that this
Product owner, where are you? Product owner.
Shall I fold it? But the cut, is it okay?
Put on a scale, right? Yeah. We want to try with the scale. That will be a lot easier. The edges will be sharp if you use the scale. Really hard. Right. Sing to the beat. When it all stop. So yeah. Sing to the beat. When it all stop.
Tape, you can use flanges or with other pieces of paper. Whatever is going to help you conquer this for maximum velocity. It doesn't have to be perfect. Let's not let perfect get in the way with good enough.
Guys, I got one correction to ask. I thought you'd roll it the other way around. It's not looking straight to me. It's not looking parallel. Is it parallel? Okay, for me somehow it looks off, little off. So it's going to see the engine inside and a seat, right? So if you make it like this, because it should be rectangular. Okay, we got a yes from our product owner on this. Okay. So we need very simple. Yeah.
Oh my god. Slowly.
So put it more. Put it. So that's the rebel.
Glue.
More glue.
Take it out.
It's not looking straight. This is data.
No, put it on this. Put it on the bottom.
Yeah. And press with this.
Reinforcing it so that it doesn't break when you jump on it. Not when you jump on it. Not to worry.
Can you be a proxy product owner? Oh yeah.
And it's strong also.
Let's throw it once.
Huh? Yeah, let's throw it once. Evelyn is good with that. The glue would never have held it.
Yeah.
Yeah, I think that's
Absolutely.
great idea.
I got it right. My definition of done is like this height of a drop, but it should not break. Accepted. So next you guys have to connect the. So you're going to move the next story. So you can probably move the car to in progress. So next, these are the side. Just glue it.
That's in progress.
We need one more.
Okay.
These are the ones we need.
Yeah, okay.
What is this time?
So they're looking at the second one, but I think you guys know my first module was we're making 3 today.
They're throwing it out?
These are coming from inside. It's going to be plus there.
No, I think this
And
one
this
goes
one
on top. No, this thing has to come on top.
This is sustainable. This goes up.
Yeah, because see, this is the way like this.
Is there a front end?
Yeah. That's
But
the
then
way.
it has to go down a little, see? Okay. It has to be in line with this. That's what I said.
I think we need not to cut so much in advance.
We can always cut out the extra, right? We can always cut.
How's it coming, guys? I want to see the first demo itself. That was not done for me.
Yeah, just
You can't move to the part 2 before you finish the first frame. Sorry. You guys are work in progress is waste. So you guys are creating parts which are not needed right now. You should finish the frame before you move to the next one. These are cutting stuff which is not needed. So stop.
That's all. And then the front is flush, the front is flush, the rear is flush, the rear is flush. Yeah, this one goes on this side. Here's how you know. Strut means back. This is the back. Which you can't see there, but it's not easy to see. There you go. You got it. This is the front. This is where the engine goes. Oh, the auto, rear engine auto. Glad you guys asked.
No. It's our hunch. It's our hunch.
That's going to be strong.
It's our hunch.
Yeah,
It's our hunch.
So this is not connected. This is a rear engine.
Okay.
You can also put passengers and driver here.
Okay.
So see, this is protruding outside.
2 holes and these 2 holes. They go through these 2. That's actually how you attach this thing. Now the other thing to know is this is the back. With the 2 is the back and that's the front. And this part leans back. So that's the front. So you had it exactly at both. So it'd go on this side. Just like you had.
Okay, I see. I can test that one.
Success!
Let's take this and then discuss the others.
Oh, beautiful.
This is
Can we get some video of this test?
He is right here.
Can I,
So definition of done is if it drops from this side, it should not break. Are you ready, Joe? 1, 2, excellent. So there is a little bit of a flaw in the design, right? As it dropped, I noticed. See, this is the rear engine module. Look at the picture. Okay. It has to be. This has to be small, so the engine fits there. Okay. And then the front is where the guy sits in the passenger side. This way, this will not fit. So this has to move a little bit inside. Okay, big. So basically, it's a case has to move around.
Looks good, Team Transformers. The strength is right there. Now that's it. So bang, bang, and then the other side goes to the other side.
So this is the front.
Yep.
That's it. I think you're done with the first two stories. Last is the pedal plate.
It would not break. Exactly.
Solid, just solid. There's one different, but it's okay.
Yeah. That's fine. We need a little more tape here.
Yeah. Because it's a USB.
Why? Oh, okay. Oh, fantastic.
Inge more of 4 hours time. 1 day la not allowed.
Alright.
Bade company la use 4 days.
So product was not.
Like this,
We need 2 hands.
Yeah, I said.
Masterpiece.
Thankless and busy job.
Yes.
It looks good. But we need, I want to compare it with that car. So if you look at the car from there, that's a good car. So this looks very similar.
Yes. You can be approximate. How does this go?
Guys, I want to see your face because this is the back.
Okay. This is the back.
Look at the difference, guys. What's the difference between the two? This is a good one. This is also a good one, but there's a fundamental flaw here. So you have reversed the frame thing, so this rectangular stuff should go outside. That's all. But otherwise, it's pretty stable. I think I can accept it.
We can fix it.
Next iteration, if you don't have,
We can fix it for you.
rotate it around. So that's all. Otherwise, it's pretty good. And it should. That's it. Otherwise, it's very nice.
Sure? Okay.
Yeah, 2 on the sides, 1 in the middle.
Okay.
One extra there on the side.
Oh, true. Thank you.
1 extra.
You guys can apply this not just to paper, but to any company that needs Agile and they want to go fast with quality. So let's talk about that. And then let's take some photos of each other's work. You know what? All the energy is right on the work right now. Let's have you guys stand up and show them what you got. And let's take some team photos if that's okay. So as teams, if you guys wouldn't mind standing up and holding the current version in progress. Team WIKISPEED, if you guys would stand up.
Yes.
And let's take a team photo.
Let's put all our hands.
Okay, pose.
Oh, very cool.
1, 2, 3. WIKISPEED.
Indie speed.
Okay, sure. Well done. You guys put together. Please don't throw that away. I think I need it. Beautiful.
Yeah. Thank you.
All right. I have something to be desired. Hold up.
He's giving us dirty looks.
Team Boot, hold up your system so people can see.
Guys, hold it up. Hold it up. All right. Come on.
Good job.
Get in together. Get close, faces close together, all of you. Ready? 1, 2, awesome! Great, guys. And here, let me take a close-up of the logo near the car, because you're amazing.
Okay. We didn't get a logo.
Smile big, because you're in the picture too. Bigger than that.
You've seen it? Okay.
You guys are awesome. Okay, team, please get together and look happy. 1, 2, awesome! Okay. Guys, everybody smile big. Awesome! Smile bigger than that! Oh, there we go. Better. And if I can get the close-up with the logo, you even labeled the car. You guys are awesome. Fantastic.
Stand the test of.
Here's what another team that looks like this did. Here they are holding up 2 cars, and they have their backlog. Same product owner, and also there's also
Standing here.
Yep. So we've had some product owner continuity, and here's another team that made 2 more of these. Here's one. Here's the other. If we think about the Agile Manifesto, it only says software once in the 4 values, right here. So if we translate it like this and say, we value delivering value over comprehensive documentation, we can use the same manifesto and apply it to any industry. And we can use that as a ranking to say, how agile are we? We'll take more photos at the end. There's obviously some pride. I like this. Identifying with their work as work worth doing. Not just being paid to show up to work, but they actually think they're making the world a better place. They're building their mastery and delivering on their life sense of purpose. And then, sustainably, they'll deliver at 10x velocity of standard teams. That's called Agile 3.0, and we don't have time to dive into it, but I'll point you guys to someone, if that starts to be exciting to anybody here, Nikki Hare, N-I-K-I-H-A-R-R-E. She studies the science of this. She's the Dean of Psychology at Auckland University in New Zealand. And it's absolutely morale as a multiplier for velocity. The statistics to provide that evidence, and the science of how to make that happen in your business.
So what's the article called? Nikki Hare?
Nikki Hare.
Yeah.
And she has several. That name will attach you to this type of work. N-I-K-I-H-A-R-R-E. She's awesome. Here's a company at a time. This is an Agile 2.0 transformation. This company has 74 employees, and they rented out a lodge for 2 days. And they did a combination of a certified Scrum Master course for all 74 employees, everybody, from the janitor to the CEO. And here, they're doing a retrospective based on the 4 Agile values to say, what do we do? This is the HR department at this table, and every table is a different department. What do we do that enables each of the 4 Agile values, and what do we do that slows it down or inhibits it? And they're creating a backlog to address that. Here's a group of nonprofits, and that's me. I'm helping them create a backlog for them to relaunch as Scrum teams. So there's multiple companies in this large atrium. Here's a set of 23 companies in Italy. It's mostly just their CEOs and CFOs in the room. And they're relaunching their entire companies as sets of Scrum teams using Agile values and using XP and XM practices to deliver quality. There's Simon Cicero. He's translating in real time. There's me. And Simon also is a deep thinker in this space, so he had an enormous amount of value to add to that session. This is in Rome, Italy. This requires a tremendous amount of motivation because you're not even just relaunching one team and getting to try something different in the way one team delivers work. It's a whole company. You'll see me high five all the time. We drink a lot of beer and listen to a lot of upbeat music because we have to. It won't work any other way. If you're not high morale about the Agile adoption, it gets stuck. Especially when you're doing it a whole company at a time. But if you can hold that level of enthusiasm, the entire company can flip the bit and launch with Agile values, which lets us have faster delivery, lower cost, happier teams, and higher quality. Agile 2.0, we've done it with human resources, marketing, design departments, finance, legal, senior management, hardware development, and mass manufacturing. For more information on any of this, you can go to the website of my day job, solutionsiq.com. It's full of white papers on Agile, Lean, Scrum, and extreme manufacturing. So if you want to send a link to some of this stuff to someone who is not in the room today, that website holds much of it in the blogs, white papers, and articles. How do you make an increment of a physical product in a single iteration? I'd like to show you an example through Team WIKISPEED. Here's a safety iteration. So in the United States, we can't even legally sell a car until it passes a wide range of government-mandated safety tests. It's called the Federally Mandated Vehicle Safety Specification. If we printed out the list of all the tests, it'd be about that big. Here's how we passed one of them. First, we choose the test. In this case, it's the NHTSA Side Impact Test, the National Highway Transportation Safety Authority. First, we model the test as a three-dimensional drawing. So here's the side of that same chassis you just made, but longer. You guys made an auto-sized one. This is the 4-seat car that we sell in the United States. And it's being smacked by the deformable side impact barrier to simulate that test. Then we perform that test physically. BAM! This test costs $10,000 US every time we run it. We make iterations of the car every 7 days, every week. Thursdays are our demo. I was actually at 7 in the morning on the phone with the team calling into our weekly stand-up and weekly demo along with people from 20 countries calling in. And they film a YouTube video and they upload it to YouTube. So if one of you were curious later, you can go to youtube.com/wikispeed and see demos going back years, different iterations of different cars. We can't afford to run this test every week. But I just told you, we sell new versions of these cars that meet road legal spec every week. This test isn't the success metric. This test is used to make the simulations more accurate. The simulations are so accurate now, they're directly accepted by the government. We run this test whenever we can afford it to check the accuracy of our simulations to see if they give a similar result. And then we run the simulations every week. Then we iterate on that design. That was an example of a failure. That car being hit in the side, it pushed in about 4 inches, so about that much, on the driver's side. That would break their ribs. It was survivable. We passed the test, but we didn't get the top score. We sent that video immediately out through the team, and a father and son volunteer group cut an updated version of a side crush structure and had it applied the same day. Because these items bolt on, like you guys saw when you were attaching the suspensions on the side, we can bolt them on like a hot fix to any car that comes back into the shop. We don't have to build a new car to even dramatically change the safety performance. Here's how we try to make the car a little more beautiful every week. First, we start with a CAD, a 3D drawing. This one was also drawn by Rob Morbacher of More Composites. He sent it to us through Dropbox. We decided we wanted to build it, we voted on it as a team, and so we cut it out in foam in 1 day. We used what's called a CNC machine, a computer numerically controlled machine, where you basically hit print, and it has this arm go around and it cuts off any part that's not car. So in 1 day we had a full-sized car that we could walk around and look into, made of foam. Then we laid it up in structural carbon fiber in 1 day. So 2 days later, we're producing a carbon fiber car body. Then we went to the largest auto show in the world, and we were terrified. We had no idea how this was going to be accepted, and all the existing automotive companies are going to be all around us. We completely panicked. Luckily for us, the car was beautiful. It was put on the main floor of that auto show between Ford and Chevrolet and around the corner from GM. That encouraged the Discovery Channel to come check out what we were doing. And they came and shot a mini documentary on us. And we asked them, may we use this footage again in promotional materials for our team? Now these iterations I'm talking about, the first time we ran them were multiple months long. We put in cards in the backlog to reduce the iteration time, to make our tests run faster. Now we run these in 1 week. We took that video the Discovery Channel shot and we packaged it into a video to crowdfund the next iteration of the WIKISPEED car. And I'm going to do some audio if the sound guy's ready. Sounds good. I think we're good. So we take the Discovery Channel video and use it to crowdfund through a site called Indiegogo the next iteration of the car.
This car gets 100 miles per gallon. This car is completely modular from the body down to the engine. Transform it from a 2-seat convertible to a 4-seat family car to a pickup truck. We've made the plans to build this car completely free to the public online, and this car is fast.
100 miles per gallon worth of awesome is how it's running.
Introducing the world's first gas-powered 100 mile per gallon sports car, available open source to the public.
I'm Joe Justice, the team lead of Team WIKISPEED. This carbon fiber mid-engine rear-wheel drive aluminum extruded chassis supercar is $25,000. It's a race car. It's extremely basic. We're now jumping the gap to bring as much of that technology as responsible, as much of that sport racing performance, and most importantly, ultra efficiency in an even lower cost package that's a comfortable commuter car for people to enjoy every day on their way into work.
We want to bring this incredibly efficient technology to your driveway. Our goal is to make the next model of the WIKISPEED car a realistic option to save you big bucks at the gas pump.
Team WIKISPEED runs on materials, machinery, and person hours. Funding allows us to turn all of those resources up to 11. We want to complete 10 additional crash tests. Also, additional fuel economy testing that's certified by the EPA.
Our project is funded for the people and by the people, and your support is going to bring the 100 mile per gallon revolution to driveways all over the world. We invite you to be a part of the action. Help make the world completely awesome. Let's drive WIKISPEED.
The next iteration of the car from the first iteration. So part of this practice that we demo early, even in hardware, before we think it's really done. Like I said in that video, it was like a race car. It was very basic. By showing it publicly, even though it wasn't at this polished end state, people started buying them already. We got more investment through public demos in hardware, just like we experience in software. People re-up their commitment as you go along. This is exactly the organic funding model we use, where we don't try to finance the project multiple years out. We try to make sure we have enough budget to run the next 7 days, and that we prioritize enough awesome in the next 7 days that people will want more awesome the next week. This is a picture of a polar bear giving a high five to a robot in front of a supernova. Team WIKISPEED isn't actually about cars. We talked about cars, we built modular miniature cars, we talked about test-driven manufacturing and how that's required to have safety and quality when you're building a new version of a hardware product every 7 days. But that's only a small part of what we do. What we're really all about is rapidly solving problems for social good. We have a micro house project right now where we're helping make a $100 house with a lockable front door, a clean bathroom, and a clean bedroom, to help end involuntary homelessness worldwide. The first project I worked on that was Agile outside of software was a project to help deploy the polio vaccine in congested urban India slum neighborhoods where it was needed the most. Team WIKISPEED has backlog items for all types of social good projects. If I got to ask everybody in this room a favor, it would be join Team WIKISPEED. Help us do awesome and change the world. And get hands-on experience with Agile for hardware and all types of social good projects. You don't have to join Team WIKISPEED to make good stuff happen. In about 2 hours a week, you might be able to change the world for the better over the course of a month. You might have a working V1 of something that makes your neighborhood, or maybe even the whole world, a little bit more awesome. The average Team WIKISPEED member spends 2 to 8 hours a week working on the backlog with the rest of the team all over the world. Join in. Email info@wikispeed.com and help solve problems that are worth solving. And you get to drive fast cars that are very efficient, which I like a lot.
Okay. Can we build them in India?
Yes, you can. Okay. Absolutely. And you just did it in miniature.
So
imagine that, but 10 times bigger.
So who built the engines for this stuff?
We'll do Q&A in just a second.
Oh.
Yeah, great question. But if everybody in this room spent 2 hours rapidly solving problems for social good, whether it was with Team WIKISPEED or not, I'd encourage you to use Agile methods, so that way it doesn't take a lot of money and doesn't take a lot of time until you have a working V1, where it's actually making a little difference. And you've completed a whole user story, thinking it like a user story map, the shortest path to the minimum viable product or the minimum viable feature. If everybody in just this room spent 2 hours a week rapidly solving problems for social good over the next month, it would be so awesome. It would be like a polar bear giving a high five to a robot in front of a supernova. Folks, thank you very much. With that, you've graduated. You have some hands-on experience with Agile for hardware projects. You have some of all the basic best practices to make this responsible in any industry. Please go apply Agile anywhere and try to make the world a better place. I think the next session is already about to start, so feel free to get to the next session. If folks have questions, you can reach the whole team, not just me, so you can get their whole perspective at info@wikispeed.com. That's also how you can join if you wanted to. You can just put in the subject line or in the email, I'd like to ask about joining. So you can ask questions there, even if you have to run to the next section, so you can take a picture of the screen and run out. But if folks want to ask some questions, I'll stay until the next speaker pushes me out, and you can ask Boo, JP, or myself, the guys in the Solutions IQ WIKISPEED shirts, and we'll do our best to answer your questions.
I would suggest, Joe, that we do our side, so we can make it up. So just quick points is we are building WIKISPEED shops, trying to do in India, 3 of them, Pune, Bangalore, Mumbai, voluntary work. Also at Solutions IQ, we are looking to hire 4 coaches at this point, consultants, technical as well as Agile coaches. If you're really interested and want the offer letter today, please see me. Done today itself.
Awesome pitch. Awesome pitch.
That's all. We thank you again for coming, and we want to arrange the room back. So I would appreciate if we can take out things that you took out your bag and move them in the room into this bag before we leave, so we can get into the right place.
Guys, thanks for spending time with us today.
Business cards are here.